Hi, in previous video, we talked about the basic usage of EDB, but analyzing an NFT like that is just too inefficient. So this time, let's try some advanced feature. I'll use this contract for demonstration. Like many NFT, there is a mint function which calculates SHA-3 with some random input. The latest Go Ethereum has renamed the SHA-3 to KECCAK256, but that's just a rename. I'll still use SHA-3 here. The parameters are block.timestamp, token ID, and the message sender, which is your wallet address. Then it mods 100 to get a random number between 0 and 100. Next, it compares the value to 5. If it's greater than 5, you get a common class NFT. Otherwise, you get a rare one. So a user has about 95% chance to mint a common class. This is just a demo, but most NFT are nothing better than this. Some use block.difficulty or block.number or the combination of them, but that makes no difference. Let's load that transaction with command load. This time we don't use single step. Let's run some advanced tracer, low level and high level tracer by command low and high. Then we just continue running until it finishes. The low-level log is output to the console while executing. To get the high-level log, use command OP, which means optimize. It will be printed to console and saved to the file. From the high-level log, we can easily see those input parameters for SHA-3. Here are block.timestamp and storage value at slot 0 and message sender. These values are not random, they are predictable. On BSC network, if you send a transaction, normally it will be mined after exactly 2 blocks. Because BSC generates new block every 3 seconds. So to predict, you need to use current timestamp plus 6 as the parameter 1. For parameter 2, just read it with the storage API at slot 0. For parameter 3, it's your wallet address. Then calculate the SHA-3 with these parameters and mod 100. If the result is rare, you build and send the minting transaction. If not, repeat the calculation on the next block. This is what the high-level tracer for. It shows parameters and algorithm in a more human-readable way. But sometimes it may be buggy. For example, the caller here is 32 bytes, but actually it's 20 bytes. You can see that in the low-level tracer. Because of the ABI.encode pact in Solidity, which packs message.sender to 20 bytes. So I always compare the high level with the low level tracer log, because this one is more accurate. In practice, to locate the algorithm, you just mint a token and search for its ability value. For example, you just mint a token with strings as 14, which is E in hex. So search for the hex format 0xe. You will find the algorithm in 1 second. That is just predicting with one wallet. To increase the chance, you may generate a lot of wallets. Calculate all the results for them. If wallet W got a rare result, you send a transaction to send some Ether to W to make sure W has enough balance to mint. Then you send a second transaction to mint with W. Of course, you can also deposit enough balance to all the wallets. Then you just need to send the minting transaction. Some NFT has features like upgrading. To level 1 token can be upgraded to one level 2 token. Of course, with probability of failing. Once you fail, you lost everything. But this can also be predicted in the same way. So much for the predicting. In the next video, let's talk about how to prevent being predicted like this. Thanks for watching.